Okay, this is the answer key to worksheet 7. So this first step, what I want you to remember is that if you have a Grignard and you have any type of acidic proton, that first step will just deprotonate the alcohol, because remember, Grignards are extremely basic. And the second step would just reprotonate it again. So this is like a no reaction, but I would probably draw this over no reaction, but either one would work. Okay, don't forget that about acidic protons, and Grignards are lithiates. All right, the second one, we have H3O plus. This is an acid, or a ketal, I guess is what we would call it. It's a ketal, which means when we do hydrolysis, this is going to become acetaldehyde. And then these will become hydroxides here, right? And I want you to remember, we normally use ketals or acetals to protect carbonyls, but you can also protect diols this way as well, right? This is a possibility. And then when you use the Jones reagent, we're going to do it with this one here. Actually, you did Jones with this. You make CO2 and it'd leave. But we don't care about this compound. We care about this one right here, right? Formaldehyde is super easy to make. And this is going to be the original compound. But then we're also going to have Jones reagents, chromic acid is going to be in acid. So we're going to have tautomerization right? And then I'll just use like water. Take this proton, make that there. You can't see that at the end. You get to here, and then you can also just do 2 more steps. And eventually, you're gonna make what's called a catechol, which is what the functional group that poison ivy has that reacts to your skin a lot. So this only happens because you make an aromatic ring. Remember, the enol form is usually way less stable than the ketone form or the carbonyl form, right? So the only reason this happens is because you have extra stabilization from making the aromatic ring. Good, all right. Last problem, I want you to notice that this is a ketal, but when you make the hydrolysis product of it, go back to the carbonyl, one alcohol is gonna be, so you're gonna cut these bonds, it's gonna be part of the molecule, one's gonna not be part of the molecule. So if I were to draw this, I would draw it like this, like that, and then I would have on the other side, you'd make ethanol. So just that you know, like these don't always have to be in the same molecule or 2 different molecules. You can get a little bit of a mixture as well. Good. All right, for the sake of the video, I'm actually gonna do the bottom mechanism first, and then we'll do the top row. Sorry, just grabbing my red pen, so it might be useful. So the first step of this bottom mechanism is taking the H plus. I'll have all my arrows be red and my structures be black. That seems like it's... And then... I won't draw the arrows for the resonance structure, but it's going to be this. The carbon's very electrophilic. So the next step is going to be to take ethanol. Now that come in an attack, kick that up. Right, ethanol. Right, and now I'm going to do some proton transfers. Basically, I want this water to leave. So this is basically a 3-step process. The first step is you're going to add ethanol. Second, you're going to kick off water, which is going to be this part here. And the third part is you're going to add the second ethanol. So when I do this for the next one, what I need is I need a base. And get to what's called the hemiacetal. right? Oops, I was trying to do this in a minute. Then I can take my acid again, protonate my water, so that now or protonate the alcohol, so now it'll be a good leaving group, right? This will leave, and that's like the beginning of the next steps, right? So that was like stage 2 was get water to leave, and now stage 3 is going to be add in our second ethanol molecule. When that happens, you can see the whole structure. Do the final deprotonation. We get to the acetal, right? So this is kind of like 3 steps. 1, add alcohol. 2, H2O leaves. 3, add ROH. So this one up here is deprotecting an ketal. When I was taught, we called them all acetals, not ketals for protected ketones and acetals for protected aldehydes. So if I say it wrong, I apologize, but that was the way it was taught. So this one is going to be basically the opposite. So if we're doing this mechanism, stage 1 will be ROH leaves. 2 will be H2O adds. 3 will be ROH leaves. Right? That's like the opposite of what we had before. So the first step here, if we walk backwards, the last step is deprotonation. So the first step here is going to be protonation. I don't really care which one you protonate of the 2 oxygens. I should probably do this first. Let's number these carbons. Right? I'm going to just do this one because it'll be less crowded. And then let's... Oops. Here, now we're going to have this leave. This, of course, has a resonance structure. One, two, three, four, five, six. 1, 2, 3, 4, 5, 6. That's here, right? But the next step is we had ROH leave. Now we need to add water. So let's have water. Anytime you have H3O plus, you will also have H2O. Right, now we need to deprotonate the water. So our base is going to be water. Don't ever have anything with a negative charge in this mechanism because you're in acid. If you're in acid, you don't want to have any negative charges. Everything should be neutral or positively charged. Right? So next, we added water. Now we need to make ROH leave. So that's going to be this, oops, I need to break this signal bond too. Coming in. Now we can have this leave. Three, four. Here, there will be a resonance structure. One, two, three, four, five. That's a double bond. Like that. And then finally, to get to this last structure, I'm just going to use H2O. 2. Pick up that proton and get us back to there. And then if you unwind the chain, you'll get to there. So there, that's the mechanism for deprotecting an acetal. Remember these 3 stages of the mechanism. Okay. Then we got some synthesis problems. Provide a reasonable synthesis to get from the reactions to the products. So this one, remember, there's basically 2 sides. There's the red side and the black side. The red side stays the same. The black side oxidizes to carboxylic acid. So what we need to do is we need to do acetal protection. Put the headphones on. Right? Then we can use Jones reagent. We'll get this. Then we can use H3O plus to get back to the aldehyde. And you'll get there. So this is like protecting groups. All right, for this one, we see that we start with 1, 2, 3, 4 carbons. To this 4th carbon, we add a methyl group and an ethyl group. So the way we do this is we have to use PCC. And in order to add those carbons, we need to make carbon 4 electrophilic. And we do that by making it an aldehyde. Now, we can react with something like methyl lithium to water or something to reduce this to here, but we're going to add 1 methyl group, right? Methyl lithium is going to attack the carbonyl, make an O-, and then I'm just protonating it. So, next we have to use PCC, or you could use Jones, either one works, because this one's going to make a ketone. And then to get to the final step, we got to use something like either ethyl lithium or Grignard, and then a workup step. Maybe slight acid or something. Sometimes you see these H2O or slight acid or something, right? To get to the final product here. And this will add an ethyl group. So that's going to add these 2 carbons in. Okay. Finally, we have these problems here, where in one side we're going to do something to the left, and the other side we're going to do something to the right. And how do you do the protection to make this happen? So to come down, this is actually a super easy reaction. This is the power of sodium borohydride. Right, and then using a little bit of acid and water, mild acid, right, and to protonate that. To come this way, if you use lithium aluminum hydride, it will reduce both sides. So the way you do this is you have to use a protecting group. So this is going to be, you can use something like ethanol instead, but I almost always use this one. And the reason why we use this as organic chem as the headphones is because it reacts a lot faster than just using ethanol. Right, and then we can come back here with like H3O plus and get there. Okay, that's it for this worksheet. Good luck studying for your next exam.